afternoon, teacher. My name is Susan Mboso, and this is the first part or the second part of my video project for functional programming in mobile app development. I'll go into why we need functional programming to develop apps, challenges, the techniques for solving the problems, platform integration, case studies, and then we'll conclude. So to start, why we need functional programming in app development is usually when mobile apps crash, it's because state gets messy, like a shopping cart that forgets items or a payment flow that breaks when the network fluctuates. Functional programming fixes this by enforcing rules like no silent data changes, and every state transition must be explicit, that prevent 80% of common bugs. Now, these are some of the three biggest headaches that occur during mobile app development. The first is unexpected crashes, like from race conditions when two screens try to update the same cards. Number two is unclear state management. For example, when the UI shows logged out but the API still thinks you're logged in, and difficult to debug UIs, like tracing which of 10 screens mutated a user's profile. Now, functional programming doesn't completely eliminate these issues, but it does make it more predictable and more fixable. So the slide shown right now is just a bunch of ways that we can use functional programming to solve some of the issues involving mobile app development. The first is the use of pure function in UI. So this function here um, determines button color based on form validity. This would essentially always return the same color for the same inputs, making UI behavior very predictable. The second is mutable state management. So instead of this, which is mutable, we can use this instead, which is a pattern enforced by Kotlin data classes and Swift structs. The third is functional composition, which chains operations like this shown here, and essentially it creates readable data pipelines that are easier to debug than nested loops. So for this part of the video, I'm going to talk about how how functional programming can be used in real life with an e-commerce shopping cart. So the problem, a fashion retailer was losing 15% of checkouts to crashes and delays, primarily due to chaotic state management. So multiple processes are competing to edit the same cart. That's one of the scenarios. So this would now create race conditions. Items disappearing, discounts failing to apply, and the UI would often just freeze out. So by adopting the functional programming principles, it's possible to redesign the cart as an immutable object where every action creates a new version rather than modifying the existing one. This would eliminate corruption risks while making every state change a bit predictable and debuggable. So pure function is going to handle critical logic like coupon validation, tax calculation in isolation, and which will now ensure rules will be applied consistently regardless of when or where they were called. So the results of this, post refactor checkouts would drop in 2% or could drop by 2%. Cart updates can become 6 times faster, and inventory accuracy can reach up to 99.9%. Functional programming discipline would transform, let's say, functional programming discipline will transform the whole checkout flow from a liability to a competitive advantage, which it could even handle something like Black Friday's traffic spikes without much system degradation. To conclude, I would say functional programming isn't just a technical choice, it's also a competitive advantage for mobile teams, because by enforcing immutability, pure logic, and explicit state transitions, functional programming will eliminate categories of bugs that plague traditional imperative code. The e-commerce case study that we looked into proved that what began as a crash-prone, unpredictable checkout flow became a reliable revenue driver simply by adopting functional programming principles.